Last class I have finished different conventions in orthographic projections. Just a brief review. If there is a line as well as there is a hidden line, you see if you mark it both these cases, there should not be any gap between the joints and it should be dashes of uniform length and it should be joined together. Up to this I have finished last class. Now, let me start with few examples of third angle projections as well as first angle projections. We will start with simple example and we will go to the complicated, then curve faces examples. This is simple cube having a hole throughout this, and this cube has been visualized by this direction. Once there is a direction has been given, this is the direction where we are visualizing this object. That means this face will be frontal face or front view will come from here. Now, let me take out this view, 3D picture it has been drawn, and if you look at here and different surfaces has been marked, it will be better if you mark it different surfaces A, B, C, D front face, then G, H, E, F back face. Now, then if once you start your drawing, in a drawing you divide into 4 quadrant. This is a beginning, divide into 4 quadrant, and if it is a third angle projection generally top view is at the top, that means top view in the horizontal plane and front view in the frontal plane. So, you clearly mark it if it is a third angle projections, this is a horizontal plane, that means top view will be lying here, frontal plane front view will be lying here, then profile plane. Profile plane means here your third angle projection right hand side view will be drawn. As I said earlier, once you draw the two views front and top, it will be very easy to make it back to your profile view. So, in a drawing sheet accordingly you scale it down, then mark your points, where is your frontal plane, where is your horizontal plane, where is your profile plane. Then name it in that front surface, name it A, B, C, D, then rear surface face or rear face you can name it E, F, G, H. Then write it top view, front view and side view, so that there will not be any further confusion while doing the drawing. Then start with this front view. So, I am looking from this side, so this will be my front view. So, if this is my front view, I draw it, then name it also. Then at the center there is a circle, mark it at the center, mark the circle point and draw the circle. It is a very simple one, just this is starting point. Then top view, you mark it top view, then extend it to your center point of your front view, extend it to top view. Then this circle at the extreme side, at the end side diameter wise, you can extend it back. Then in the top view, what you are supposed to do? This is your hidden lines. If there is a circle throughout, there is a hole throughout, if I am looking from the top view or top surface, that means this part it is not going to visible. This will be hidden line, and this hidden line will be coming because this point is merging this point, this point, this point. Particularly if I am doing it here, this is merging, this is merging, this is merging. That means if I am drawing a line here, that means from here to here I can see only one dotted line, this dotted line, because this point and this point B and D it will merge and A and C will merge. I will see this surface and this will be as a hidden line, two hidden lines here, and along with your center line. This is your center line, this is your two side face of the circle, and it is the hidden line. Then draw a 45-degree line in your top view axis nearby this 45-degree. So, project it back from the top view, you project it back, first the sides, that means first the surface, you project it back. Similarly, from here front view, the surface has to be projected back, then this intersection points has to be marked. So, these are all your intersection points. So, it has to be marked. Then circle has to be projected back. Then again in the side view, that means in this case I am looking at from this side, this is a right hand side view. Once I am looking at this, again this hollow face or this circle throughout I cannot see it. So, this will be dotted line. Here it is a dotted line, then center line has to be marked. This completes your third angle projections. Then you can name it, the surface, the way you name it A, B, C, D. This is your frontal plane or frontal view. Similarly, you can write it. You see, I write it AF, BF, AF, BF, CF and DF. A frontal, B frontal, C frontal, D frontal. This is a front face. Rear face will come into picture because this will merge, this will merge, this will merge with this. Then once rear face will be there, AE is merging, then EF is coming. Similarly, FF is coming. Similarly, GF is coming, HF is coming. Similar way you have to mark your top surface. Similar way you have to mark your profile or side view. This completes your third angle projections. Go to the first angle projections. As I said, there might be change in positions, but the views will be same. Even if it is a kind of first angle projections, top view in third angle projections, top view at the front, top view at the top, front view below the top view. And in case of first angle projections, front view at the top view will be below the front view. But the front view will be same as the front view, size and the dimension will be same as your third angle projections. So, I am looking at this object same, this is my viewing directions. Then principle, make it into 4 quadrants and mark it, where is your frontal plane, where is your horizontal plane. In first angle projections, front view at the top. So, that is why this has been marked as a frontal plane, and top view at the bottom of your front view. So, this is a horizontal plane and this is your profile plane. This profile plane, though it is in the left side, but this profile plane side view you are going to see it, it is your right hand side side view. This is your right hand side view you are producing in the left hand side. So, then same way you mark it front view, then top view, then project it back, front view to side view, then top view, then it completes, name these surfaces, how you are looking at this front view and top view. This is your first angle projections. If I look at this first angle projection and third angle projections, this is my front view, viewing direction is same. Now come back to your third angle projections. This is your front view, these views are same. Maybe this orientation, here in this case top view at the top, front view at the bottom, that case front view at the top view at the bottom. It may change with the viewing directions, but once the viewing direction is the same, the views will be same. This is a simple example for both these cases. Now, let us start with another example. That was a simple example. Let us start with example 1. Example 1, hexagonal prism with hexagonal hole in a third angle projections, and this is your viewing directions has been given, and I have named it outer surface A, B, C, D, E, then E, F, and similarly A prime, B prime, C prime, D prime, E prime, F prime. Inside surface also 1, 2, 3, 4, 5, 6, and bottom part also 1 prime, 2 prime, 3 prime, 4 prime. Then as it is, make it into 4 quadrants, then mark horizontal plane as well as frontal plane. Similarly, mark your profile plane and mark your top view, front view and right side, right profile view, because you are going to draw it for in third angle projections. Then in the top view, first draw the outer hexagon, then mark it, because it is in the top view horizontal plane, mark it AH, BH, CH, DH, EH and FH. Then because it is at the top view, that means A and A prime, this will merge, A and A prime it will merge. If you look at here, AH and A prime H, both points are coming. Then come to your mark your inside, draw a circle, then draw your inside hexagon, draw the inside hexagon. Once you draw the circle, you can do it very easily for inside hexagon. Then mark it 1 1 prime, 2 2 prime, 3 3 prime, 4 4 prime. If you look at here, this is your 1, this point is your 1 and 1 prime. Similarly, this is your 2 2 prime, this is your 3 4 5. I just put it arbitrarily 1 3 and 5. Then from there, draw your front view. If I look at there, this is my front view, that means the surface. If I am looking at there, that means this is my border line, this and this will be merged, but there are hidden lines of your inner hexagonal. Because of that, there are hidden lines. This is a front face, front view. Then mark it front face, front view, front face from where I am looking at, from here. What are the points? You can mark it E, F, B, C, E, F and B, C. If I am looking it, this will be my outer surface, this is coming, then B, C is coming. Then from there, because here it has to be marked back your front view, then extend it. Then similarly for side view, outer surface you mark it your outer surface, side view. And also inside face also you mark it, inside face. This is a very easiest one. Only if you do it systematically, it will be very easy to draw it. Here there are hidden lines. This hidden line will come from where? Inside hexagon, it will come from there. Now take it 1, then this is your 2, this is your 3, this is your 4, 5, 6, all you mark it, then project it back. This will be your hidden line. Similarly, this hidden line for your right side profile view, because this is a regular hexagon inside a hexagonal hole. Even if this is my front face, right side face will be that side, because it is a hexagonal shape. Similar surface will come in right side view. Next one is your interesting one, example 2, projecting curved surfaces. If you look at it, this is a regular feature of a cube, it has been cut it, slanted it, so that this face is elliptical, that means it has been cut it. So this is not circular, rather ellipse, but bottom part is a circular, because this has been cut it in a slanted way. So how to project it back? This is a regular face, how it looks like, this is a regular face. Then how will the circle look at the top view? See how it has been made it, this and this, it has been cut it. Now how will the curved surface look in the top view? In this case, how this curved surface will look at? It is a regular section. The curved surface look like a circle. Now I cut it, inclined. Then how the curved surface look like? How about in the right side view? If this is my front view, what's about your right side view? Take this curved surface, take that, particularly that view you take at, this is your direction of your view, that means this is your front face, this is your direction of your view. Then draw your 4 quadrants, mark your horizontal plane as well as frontal plane, then draw the front face. If I am looking at here, that means this surface I can very easily see it. This is your this surface. Then mark it in the top view as well as top view, which part you can see it very easily. This top view you can very easily mark it, because once you are looking at the top view, that means this point and this point will merge. Similarly, this to this point will merge, this to this point will merge, it will come as a one line in these directions. Then mark your side view. Here in the top view, how it looks? If I am looking at the top view, how it looks? It is a circle or it is ellipse? Why? Tell me. In the top view, it is an inclined surface like this. In the top view, because there is a surface is like this, then it is coming right. Then what will happen? This point will merge this point will merge this will just let me finish, you can see it. Mark in the top view circle points, regular points you mark it, 12 number of equal points or 20 points you mark it. Then once you mark it, you name it. Once you name it, you project it back. Project it back, this point to project it back in the surface. This is your inclined surface. Project it back these points and mark it these points. These points also project it back to your side view. And respective points, suppose this is your C point, with respect to C, it has been projected back and this point has been projected back. This will be a point. Then each coordinate has to be located. Each coordinate has to be located in the side view. Let me see how it looks. Is it clear? Now in the top view, it looks a circle, because if you look at here, it is caught it, because this point has to be merged. Bottom face is a circle, bottom face is a circle, though it looks like a curved surface at the top, but this 1:1 it will be merged. So that means it will be looking like your circle, it is a circle. Then here this is a curved surface, this circle, the moment I looked at the side view, how it looks like, this is a ellipse. So this is the thinking, projecting a curved surface, and it will be easiest if you mark it, name it one by one, then project it back to your corresponding front view, then again from the top view we project it back, from the front view we project it back, intersection point you will get automatically the viewpoints for your side view. Once again, it is a complete view. This is your top view, this is your front view. These two lines are what? These two lines are, the circle is inside and it is inclined, it is a throughout. These are all your hidden lines, and this will be your center line, because this is a circle. So then example 3, look at this surface. Though I have covered it earlier also, example 3, how it looks, I said earlier, because different surfaces, we have just made it different colors, yellow, blue, orange, these colors are there. Now if you look at front view, how these colors are there, front, and this is your top view, to make it understanding, better understanding. If you look at here in the top view, I am looking at the top. Now this is inclined, so that means you should not say that in the top view you should see as an inclined surface. No. What will happen? This point to this point will be merged, this point to this point will be merged. So it will be looking like the surface. So it will be the surface from here to bottom of the, from here with this surface. This is your top view. But inclined face you are going to see it in your front view. This is your continuation of example. There are few examples. Now there is another features of your example, curved faces are there. Now you are viewing here, and there is a hole throughout the section. There is a here also there is a curved face, or you can say a circle, half of the circle. Then how it looks, if you can see that if I am looking at the top view, this is my top view, that means this point will merge, this point will merge, this point will be merged, this will be a circle, this will be a circle. So in the front view the circle is inside, that is why there is a dotted line. In the side view again the circle will be a dotted line, right. Anything else you are looking at the difference? Similarly example 7, I am looking from this, why I am looking this direction from here? As I said, you set a directions, your front view should be such a way that maximum number of parts you can visualize. As far as possible, number 1 point is your maximum number of parts you can visualize or components you can visualize. Number 2 point, as far as possible avoid hidden lines in your front view. I can see these directions also front view, I can see these directions also front view. If I look at from these directions, this will be hidden line. If I look at here, this will be again hidden line. So I choose it so that I can see here. These are all typical examples, so maybe later on we can discuss. I will stop it here for orthographic projections of example 1. Let me go to the second part of your orthographic projections and last one for this of orthographic projections before this assignment and the other part. This part I have already covered. So I will stop it here. Next class I will start dimensioning of the orthographic projections, how the dimensioning has been done and what are the principles behind the dimensioning.